Are nightmares of data breaches and the APTs keeping you and your CISOs up at night? You probably know by now you should be hunting, but what should you be hunting for, and when and how? Rob and I have a definition of threat hunting we've been using for a little while that says threat hunting is the collective name for the set of manual or semi-automated processes that you do to find the bad guys, the security incidents in your network. Probably the ones that were missed by your automated detection systems that you already have in place. And there's a lot of interest in this topic right now. But weirdly, there's maybe not so much good guidance on how to figure out what you should be hunting for. Everybody's telling you, yeah, you should go hunt. And if you go into the vendor area, you'll see lots of threat hunting messaging going on. But how do you know what you should be hunting for? What are the priorities you should be setting for the things you're hunting for? How do you create from that to going to coming up with a finished hunt plan that you can turn over to your hunters and let them start hunting? Well, we thought this was kind of a big problem, and we wanted to do something about it and have a little bit of fun at the same time. So Rob and I are going to tell you a soothing bedtime story about how you can solve these problems in your enterprise and come out with an actionable hunt plan. So snuggle in, relax, and enjoy. Go to hunt, then sleep. If my mic works. Okay.
A lot of suspense. There we go.
There we go. The bad guys are inside your network today. From finance to HR, they creep. If you expect to ever rest well, go to hunt, then sleep. So thanks for joining us. My name is David Bianco, and I'm here on stage with Rob Lee. I'm a malware researcher. I'm a security researcher, but a little bit different than the kind that you will see here mostly at Black Hat, because most of the people who describe themselves, I think, as security researchers here are like malware researchers or offensive exploit researchers, or, I don't really do that. My whole career is focused more on protecting networks by doing incident detection and incident response and kind of sharing what I've learned with the rest of the community. And so my research mostly focuses on better ways to do incident detection, including threat hunting. I'm also the main instigator behind the threat hunting project, that threathunting.net. And I will turn this over to Rob, and he can say a few words about himself.
Sure. Hey, so I'm Rob Lee. I run a company called Dragos, which is ICS focused, and basically my whole career focuses on things that blow up and can hurt people, so we try to keep it from not happening. I teach at SANS Institute as well. I've seen a bunch of you out here from my previous classes, either on the threat intelligence side or the ICS incident response course. But most people actually know me for writing the Little Bobby comic. I like to pretend I'm technical and know things, but everybody always comes up to me and goes, I read your stuff. And I'm like, oh, my latest paper? No, the comic book. I'm like, oh, okay, that's cool. So Jeff Haas obviously can't be with us today, but Jeff Haas is the illustrator for a lot of the stuff you saw on the screen today and we'll see. He's the illustrator for Little Bobby. And we are no Samuel L. Jackson, but we will try to narrate the story for you the best that we can. We also are not doing a hunting 101 type talk. So a lot of the stuff we want to deliver to you is actionable and things you can go back and use. However, if you're interested in some of the 101 type material on what is threat hunting, how to get started before sort of the planning discussion, we did include some links up on the slide. These are resources that David and I have worked on it before. Obviously, he runs the threat hunting project, but we also have the hypothesis generation for successful hunting paper. And that really details the 3 ways you can generate hypotheses to get started. Because realistically, because it's a human-driven process, a lot of your challenges will be around generating good hypotheses to go out and test in your environment. So that can get you started with that. We're actually going to go through, though, read you the story and get you your first 5 hunts that you can leverage in your own environment. We were serious.
We were serious. Chapter 2, a song of intel and planning. Know what you're doing before you start hunting. Prepare for success, my sweet. Take the time to think things through so you can go to hunt, then sleep. Good hunting requires successful planning, a lot of planning. You can't just take some ill-formed ideas and pass them on to some threat hunters and be like, okay, go do this. They might produce something, but how do you know it's going to be the most useful use of their time, right? Is it going to be something that is really important to your company or not? That's part of the planning process. So we're going to talk about, in this section, the 3 phases of good hunt planning. The first is how to identify the adversary tactics and techniques that your organization most specifically should be concerned about. There are obviously commonalities across different organizations that are, you can leverage, but in my experience, many of the organizations, because of either their industry or the way they do business, or even just the technologies they have in use, the specific tactics and techniques vary a little bit. So we're going to talk about what tactics and techniques you should be, how to figure out what you should be concerned with. And then we're going to talk about how you prioritize that big list so that you can come with a pick list, the most important things on the top. And then how you take each one of those individual things and turn them into a fleshed out plan for the individual hunt. So we'll have a hunt plan at the macro level that shows what you want to hunt for and in what priority order, and then we'll have a hunt plan at kind of the micro level for an individual hunt. So the first thing is to identify your hunt targets. The first step is to kind of look at the friendly intel that you have about your own environment. Things like the core business processes that you have, the assets that are directly supporting those. A lot of times you refer to this kind of analysis as like a crown jewels analysis. But you're maybe not only specifically concerned with things like, let's identify the mail servers and the Active Directory servers. You also want to look at the business side and see, what are the most important things that are going on in my IT environment that are actually making my business work? And it could be manufacturing, it could be intellectual property generation, depending on what your business is. But figure out what the most important things that are going on that make your business run as the unique kind of business it is. The other thing is take a look at the kind of flip side of that, and what are the things that are going on in your environment that if someone were to cause disruption in them would most impact your business. So that's where you do get into some kind of IT pieces like, if they take down the Active Directory servers, you're probably not going to be able to log in and have a bad day, right? But there may be some other things that are specific to you. So if you're in one industry, maybe you're very concerned with data breaches of customer info. If you're in a different industry, maybe you're concerned more with, like if you're in the medical industry, you might be concerned more with the security of the medical devices that you're working with, things like that. The next thing to do is, I'm going to make the whole slide here actually. The next thing to do is figure out what those tactics and techniques are for your environment, and then go to something, I like to use the MITRE ATT&CK framework for this, to find the tactics and techniques that you've already identified in the MITRE ATT&CK framework and look at the other things that are near to them on the matrix, because those are the related things. It's not so much that you're going to have to cover everything in the MITRE ATT&CK matrix. But think of this as more of I think of it as like the pirate code. It's kind of a guideline more than a rule. There are some things in here that you cannot detect. For example, I think one of the entries in the command part is something like use of multi-layer encryption. Like encrypted and then encrypted and then encrypted on top of that. That is a thing that attackers might do, but it's not something that you're going to be expected to have to develop detections for. So don't think of every one of these things as something that you have to detect, but think of them as kind of like security conversation starters, like to spark other ideas about other tactics and techniques that might be related to what you already know you want to look for. And it's a little bit of ways of getting a little bit of breadth, right? So now you have a list of things that you're interested in, and it's probably unordered and kind of looks randomish. The next idea is to map them to an attacker lifecycle model. And there are a lot of choices. Probably everyone here is familiar with, if I can get this to work, the Lockheed Martin Cyber Kill Chain. Mandiant also has its own. And again, since we're using the MITRE ATT&CK framework, just for purposes of this presentation, we're going to go with the MITRE ATT&CK attacker lifecycle. But it doesn't really matter which one you use, and you may even have your own, and there's other ones out there, as long as you find one that you're comfortable with. So what you do then is you take the individual things that you identified, the tactics and techniques, and you match them up to where they fall on the attacker lifecycle model that you've chosen. So you can see here I've kind of done this sample. It's a very small sample. Yours will probably be a lot more detailed. And on the x-axis, I've got all of the attack lifecycle phases. And on the y-axis, I have my gut feel of relative priority. I can't say that there's an industry standard scoring for priority of these things, right? But the idea here is that in most of the attacker lifecycle models, the things that are closer to the end of the chain or the model are usually higher priority because it means the adversary has gone farther into their attack and they're executing things that are more impactful to your organization. And so if you align these things, you've matched these tactics and techniques up and you place them on the grid in their proper life cycle and sort them, rank order them with what your rough priorities are, then you end up with a graph here that basically shows it's kind of like the magic quadrant for threat hunting and incident detection. These are the things up in the right-hand corner, the upper right, that you need to probably think of as your priorities. Now, what you're going to have to do next is you have still kind of a matrix of those, and you will end up then taking those and collapsing them down into a single column, fully ranked. And there, again, this is one of those situations where there's not exactly one correct way to do it, but if you think of things like whatever is at the most corner part of it, the upper right corner, that's probably the first thing. If you look at the bottom of that column, though, the bottom of that column may in fact be a little bit less of a priority than the top of the previous column. So you'll have to collapse them in a way that makes sense. Again, there's no one way to do it, but just take these as a guide and merge them into a single list. And that is what you should be hunting for and in what order. Now, the next part of that, though, is we want to take each of those individual pieces and flesh them out to be a hunting plan that you could give to a threat hunter and get them started, right? Right now, you're not really ready to start hunting on these things because you don't really have a lot of details other than a title for the hunt. So you're going to have to start with doing a little research. And depending on the way your organization's hunt program is structured, you might do this before you send it to the hunt team, or the hunt team could actually do these before they actually start hunting. Somebody has to do this, but it doesn't necessarily always have to be you. And you will take each one of these and do some research to see, okay, what does this actually mean? Match it up to what you know about your technologies that you have in place and say, well, if I did see this, what would it look like in my environment, in my specific environment, not somebody else's environment with a different kind of data set, right? And we want to get basically four things out of this. The first thing is we want to get some kind of research summary of background information that the hunters are going to get. In reality, not everything that you're going to hunt for is going to be like your hunt team's already built expertise. I mean, you're going to give them things that they don't really know that much about occasionally. And so this summary of the tactics and techniques and how they operate and what the purposes of them are and things like that is going to be very useful for getting the hunt team up to speed. Based on that, and then based on what you know about your own technologies in place and your own IT infrastructure, you're going to then create a hunting hypothesis. This is what Rob was referring to in the intro when we talked about that paper that we wrote together about how to frame your hunting questions. Like, my hypothesis is this kind of activity may be going on in my environment. If so, this is what it might look like. Once you have the hunting hypothesis, then you can start looking for things like, okay, that's the hypothesis. Now, in my data set, specifically, what type of side effects or artifacts would I expect to find if my hypothesis were true? And these could be things like, and we're going to see some concrete examples of these as we go through our hunt plan for the specific organization that we chose a little bit later. But these could be things like, I should see a spike in this, or I should see a dip in this, or I should see a combination of these events in a short amount of time. I should see something visual that would look like this. Depending on what you're hunting for, it could be a lot different. So this is one of the reasons that you have to do this kind of planning so that you can know what to expect when you're actually hunting and know what a successful find might look like. And finally, once you know what you need to find, then you can decide on some analytic techniques that might help you find that information. So it could be stat counting, or it could be least frequency of occurrence analysis. It could be visualizations or machine learning or any kind. It's all kinds of things. So you kind of make a rough plan, and that may change as they get into the hunt. That's okay, but you're going in with a plan. And the last thing I just want to mention, it's not technically part of the hunt planning, but I think it's a very important part of the hunting process overall, is we need to be able to take the successes that we have in our hunt program and automate those so that we don't have to keep doing the same hunt over and over again, because we want to have our time free to do new hunts. So even though you may have to revisit occasionally just to make sure your technology and processes didn't drift too far and invalidate the successful hunt, we really should be considering that the end goal is to try to automate it as fully as possible so that you can go off and do something more productive than just doing the same analysis over and over again. So don't forget, when you have a successful hunt, even if you didn't find anything in that hunt, but if you know that your hunt is working and it would have found it, automate it.
All right. Chapter 3, The Jungle Incorporated book. Your product plans and manufacturing deets are the things that you'd like most to keep. Rivals could steal these, not just the Chinese, so go to hunt, then sleep. In this section, I want to tell you about the company that we're going to be hunting in. So over the next course of the slides, we're going to be giving you concrete examples of hunts that would be like your 5 first hunts. And we are structuring it based off of this manufacturing organization. One of the reasons that we chose a manufacturing organization is I think it's very important to understand that all sorts of environments are different and have different priorities, and the way that you hunt in them is going to be driven just as much by those business processes that David talked about as the type of intelligence that you're actually gathering. So in a manufacturing organization, as an example, you would typically have a business network where there's your normal IT systems, your Active Directory and domain control and email servers, but you would also have your industrial control system networks. And these would be actually where you're making the manufacturing gear. In this case, Jungle Incorporated is a leading provider of jungle-themed fidget spinners. So this is what the intellectual property that they're trying to protect is. It's not exactly differentiated, but it's pretty special, and they go for a high rate, so we really want to keep that. And we're going to try to structure our hunts to not only include the type of activity that would be in a business network type intrusion, but also the ways that your adversaries would pivot into your industrial environment and then take advantage of this. Again, one of the reasons I really like this is we will often find those cultural divides inside of organizations where you might have IT security and operations technology security, and they just never talk. Or if you're a big company, take any of the major airlines as an example, they have just as much financial data and credit card processing as they have intellectual property, as they have maintenance and manufacturing lines with industrial Internet of Things and all sorts of crazy stuff. A lot of times we see siloed teams that form, and a lot of your hunting should help bring together those teams and make sure that you're looking for the gaps in the security that they're doing in those little silos. I mean, it's perfectly fine not to find a threat when you're actually hunting. I think we talked at the CTI Summit this year, and Sergio gave a presentation on this as well, noting that if your only metric for success is finding threats, you will be a very unsuccessful threat hunting team. That is obviously what we want to look for, but the byproduct of it is really supposed to be driving value to your overall organization and identifying where your collection and detection doesn't match up correctly. So let's go through our first 5 hunts here. So your plans have real merit. Don't just cover your rear. Your priorities are spelled out so neat. These are things that you'll be looking for, dear. Now go to hunt, then sleep. In these first 5 hunts, what we really want to identify are building off of the plan that we started with. So David, do you want to cover the first couple, and then I'll hit the ICS-related ones?
Just to give you a little bit of a preview, we took that piece of information off of the slide that we just saw, where Rob was talking about what this company really needs to protect. They need to protect the plans for their products, but they also need to protect the unique manufacturing details. The plans don't tell you how to make it entirely, right? They just tell you the specifications of what needs to go there, but maybe there's some unique materials that they're unusual to work with. And so in order to fully replicate this product, you would need some information from the corporate side, the plans, and some information from the ICS side, the manufacturing details. So based on that, we've come up with the first 5 hunts that this company probably should do. Some of these may be in your first 5 as well. Some of them probably won't be. But consider this to be like a concrete instantiation of the planning that we went through in the previous sections. So we're going to do a few things here. First of all, their main concern is their adversaries, their potential rivals, stealing their things, right? So most likely that will happen through one of their border connections to either the internet, or it could be through a partner VPN or something like that. But wherever it is, we want to look for data exfiltration going out of the network. And there are many ways to do data exfiltration. And so in your real hunt, you'll probably have your hunt plan, you'll probably have multiple hypotheses around data exfiltration. But the first one here is kind of straightforward, even though it looks a little bit mathy at first. We're using something called the producer-consumer ratio. And you can see more about this at the URL on the threat hunting project on the bottom of the slide. But basically, it's a measure of what I call the shape of the individual system's interaction with the network. It's a ratio of the bytes produced to the bytes consumed. So that is bytes sent out onto the network versus the bytes downloaded from the network. And in this case, quote, the network is a little bit different depending on what type of activity you're looking for. One thing that I find interesting about the producer-consumer ratio hunt is that you can use it to look for two different things with the same exact process. First of all, we can use it to look for data exfiltration, that is, information leaving our networks. The idea is if a computer's individual PCR number is let's say it's, starts out at 0, which is the midline. It exactly, it doesn't really do that much. Maybe it starts out at 1, I don't know. Wherever it is, it's there because of what that computer is typically used for. So like a person browsing the web on their desktop probably downloads much more information than they send. They send small HTTP requests, they get giant GIF files and streaming videos and things like that. File servers might look the exact opposite. A file server might say, I get very small requests, but I send lots of data out to the network. And that's okay because the PCR number by itself doesn't really tell you that much about whether it's being misused. What you do is you look for the shift, the change in the PCRs over time. So I did a simple analysis in our testbed environment where I had a number of hosts that I then proceeded to compromise and do a data exfiltration. And I collected the information from the testbed and computed the PCR for like the previous month. And you'll see that on one axis. And then the PCR for the time period of the week that had the malicious activity in it on the other axis. In many cases, things didn't really change. Like that system was not compromised or touched and its role didn't change, so it basically stayed the same. And that's where this line comes in. That line is the reference point for there was no change. Anything on that line is by definition fine. Anything off that line in either direction starts to be a little bit weird. Maybe not too far off the line, not too far weird. So we've color coded it so that when the PCR shifted positively, that is, they started to send more data than normal, we color coded that more red. And when they shifted negatively, they started to consume more data, we color coded it blue. So obviously the red can be data exfiltration, and in fact in our sample it actually turned out really well because even though we had kind of a priori knowledge about which network node was doing the exfiltration, we just did the math and came up and we found, yeah, actually that was the highest PCR shift. It was the most red dot on the graph. But the other thing is you can look at the blue dots as well. Depending on where you collect your data, the blue dots may indicate things like data collection and data staging prior to exfiltration as the attacker sits on a computer and copies things into the computer that they're going to later send out. You have to basically have your data from a different collection point, but it's the exact same data, the exact same analysis process. If you're looking for data exfiltration, you'll do this at the network perimeter. And if you're looking for data staging and collection, you're more likely to do it at your core networks. So you need network session data, you need like net flows or BroCon logs or anything similar to that. And our analysis was straight up visualization was our technique. And what we were looking for, as you can see, the artifacts that we expect to find are things that don't fall on the line. And they're probably pretty far off the line. So for the next hunt, we chose to merge two different hunts into one because they kind of are looking for the same things and they're looking through the same kind of data. So it made a lot of sense. We're looking for evidence of lateral movement because going, before you can exfiltrate things, you're probably going to have to find the things that you want around the network. You're unlikely that your initial access point is going to be the place where they have the product plans, and it's almost certainly not going to be the place where they have the manufacturing details, because you're probably not going to get in through the ICS network at first. So you will have to have an attacker move laterally to accomplish either of those two goals. So let's talk about how we find those. Again, these are both documented more fully at the URLs that you see there in the threat hunting project. But the idea here is basically two things. Our hypothesis is that the lateral movement that might be happening in our network is probably going to happen from the command line. That's not always the way it happens, but it is a very common way for attackers to get in. Just drop a shell or a shell-like program and start running, often with native commands. So we have two things that we want to look for. We want to look for shells or shell-like things like WMI services or whatever that are being started by parents that don't usually start them. So documents, Word documents, Excel, whatever, web browsers, even system services. I mean, this is kind of basic things, right? But this will all be in your process creation logs, where you'll have the information about what was started and what its parent process was. And for that hunt, mostly we want to do least frequency of analysis or stat counting. So we actually just count all the unique pairs of parent and command shell, and we find how many times that pair occurred in the data set across our enterprise. Without exception, the very common things are going to have high counts, and usually you can just ignore those. So we usually start with a reverse sort, and we look for the most uncommon things first. And this seems like, why are you talking about this at Black Hat? It's very simple, but actually it's very effective. Because I guarantee you, there are not that many times that your individual users browsing around accidentally start up a PowerShell from within Microsoft Office. Right? The other thing that we want to hunt for through this same data is kind of the next phase. They get a shell somewhere. What's the first thing that they have to think about? They want to know where they got their shell. What kind of computer that is, where it is in the network, maybe what domain it's in, who the users are, maybe what can it see in its network neighborhood, so they can maybe decide if that's the place that they need to be to gather their information, or if they want to make another hop somewhere else. And again, there's many ways that attackers can get this information, but a lot of times they just get it straight up from the commands that are already installed on the computer. So we're going to look for unusual spikes of a cluster of these commands, usually like anything in System32, like ipconfig and all these ones in there, QUser and things like that. And we want to look for spikes of those occurring on a single system in a short amount of time, relatively short amount of time. It could be a kind of large amount of time, like a 1 hour bucket even, because they just don't get called that often. And so whenever they have a spike, it's probably pretty obvious. And our analytic technique there is basically just straight up counting and a little bit of visualization with a timeline. And at this point, I'm going to turn it over to Rob here. He's going to talk about the next couple hunts.
Perfect. So once our adversary moves from the IT networks into the industrial control system networks, things get a little weird. And when you look at industrial control system environments, they're obviously not typical IT-like environments. Even though you might have a Windows system in that network, it's doing entirely different things with entirely different purposes. And we have to appreciate what those purposes are to fully understand what adversaries might need to get and how we're going to find them. As an example, in a lot of the different incident response cases and hunting I've done before in ICS environments, it's actually pretty typical to find adversaries positioning themselves on places like human-machine interfaces. The human-machine interface, which I gave a sample little graphic up there, yes, they all do kind of look like Windows 95 Paint, but the human-machine interfaces are the way that the operators interact with the physical equipment, sending commands to open up valves or spinning a turbine faster or getting a different rate of fidget spinners off the line. So adversaries tend to position there. One of the reasons I've thought this before is it feels like common territory. Usually, again, Linux or Windows environments hosting these systems. But also in that HMI, you will get a representation of what the physical process is. It's not going to give you everything you need to know, but it's going to give you an understanding that, oh, there is a valve on the network, there is a conveyor belt, and here's the type of systems I can expect to pair up off of what my logical discovery on the network is to an actual representation of it. A lot of the difficulty for adversaries in industrial control system environments is not things like vulnerabilities and exploits, it's an understanding the actual systems themselves. I often push back on a little bit of the hype in the community where we hear things like, oh my gosh, an energy company had an adversary access the system. And it's like, yes, now make the lights blink. It's a little harder than it sounds. So for our adversaries, they've got to get to that HMI to understand a lot about what's going on with our manufacturing process. Some of the things that we can look for, some of them seem pretty trivial, but a lot of times the biggest problem is actually getting data collection off of those environments. But as an example, we might see new processes spin up on an HMI. These are not environments that we should have a lot of new software applications installed on or new processes spinning up, especially not outside of maintenance periods. So there's a temporal nature to a lot of industrial control system environments about what it's supposed to be doing in any given course of time. We shouldn't see updates to systems or new processes spawning or systems rebooting outside of things like maintenance periods that they're going in to maintain the equipment. So that would be exactly what we're looking for in this environment. You could do some sort of exfiltration off of this as well and apply some of the previous hunt knowledge as well. But realistically, what we're looking for is new connections, maybe even VPN session lengths. In one environment, we were looking at VPNs into the environment from the maintenance personnel, and they would come in on a fairly regular basis. They were logging into the network about once every 2 weeks, and they would be, the VPN itself, up for about 30 minutes to an hour as they did their small maintenance. But in the same network, we saw a compromise one time that the adversary was using the VPN, but now they were coming in every day, and they were doing it for 5 to 15 minutes at a time, grabbing data and leaving. So the session length and duration would be entirely different in how they're accessing things like HMIs. And then, of course, there's things that we want to look for. But HMIs alone won't give you the manufacturing details. We will want a lot more information. Sometimes that information can be stored in places like data historians. A data historian at times is really just sort of a SQL database, but it gives you an understanding of exactly what's going on in the industrial process itself, how fast the turbine's spinning, how far did you slow it down at any given point. It's kind of the brain and memory of what's going on in the physical process. So even if I had a specification for what the fidget spinner was, if I wanted to know exactly how to make it, there's a lot of timing and interesting details around how much mixture in terms of the recipes or exactly when did it leave one section of the conveyor belt and go to the next. And again, all that information would be in somewhere like a data historian. In this location, sometimes we can get a couple different types of artifacts. One might simply be more alarms or additional inputs than normal, especially if somebody was actually doing an attack in our environment. So that type of distribution would look very different and a lot of visualization analysis taking place there. But in the same way, we might see exfiltration again coming off of these types of environments, especially if we're going to do espionage and intellectual property theft. So looking for these systems, and I think again from a hunter perspective, you might be misguided to look at it and go, oh, it's a Windows system, I'm going to do the normal things. There's a lot of different data on that system that we can start pulling off to identify the type of activity that an adversary would be doing. One of the things I want to note about that as well is, again, if you are in an ICS organization and you're looking to go do these hunts, you'll find that over the years we have prioritized a lot of network data, which is really good because a lot of information flows over the network for us. But a lot of the host-based data has typically not been collected out of these environments. And so our hunting can actually drive our collection process as well, because we can come up with a hypothesis that I need that type of host data and realize that I have no ability to collect it. So even though my hunt wasn't successful in actually doing the hunt, I then drive future processes and how to actually position the organization better in the future. And that's some of that seam sort of bridging that we talked about earlier. Go ahead, David.
Now for our final hunt, I'm going to invoke a buzzword, machine learning.
Sorry, Alex.
So one of the things that we had in our priority plan was we wanted to look for, okay, we already did data exfiltration and lateral movement. We did some stuff inside the ICS environment. And then The next thing in our priority list is we want to look for evidence of possible command and control activities or malware activities in our network. There, again, this is a situation where there are many different ways this could be accomplished, so you kind of have to break them down and do the individual hunts for each one of those different ways that you've identified would work in your area. The most common, probably, that I would venture to say probably everyone in the room probably has, is HTTP communications out to the internet. That's particularly hard to find things that are unusual in there just because of the volume and velocity of that data. That is, in many cases, truly a big data problem, just figuring out how to store all that information about your outgoing HTTP information coming off your proxies or your network monitoring sensors or anything like that. But our hypothesis is that if you can figure out how to look for that, some things in malware command and control or attacker command and control are a little bit different than regular HTTP transactions. And it could be a combination of many factors that are different, such as the length of the session, the order of the headers that they provided in their requests, the URLs that they're going to, even the domains, etc. There's many things to look for. So this actually makes it a really good candidate for doing some machine learning to help you. This is a kind of a situation where I said earlier at the beginning where some of these processes are semi-automated. Well, a friend of mine, Chris McCubbin, and I released a tool, I think early last year. It's available on GitHub, called ClearCut. ClearCut is our proof of concept to show that you could actually get some value just by applying a simple machine learning model to your own HTTP logs to find the things that are a little bit different or odd. And I'm not going to go into exactly how machine learning works in my last 8 minutes of the presentation, because I am not a trained auctioneer and I cannot talk that quickly. However, I will say, please, if you're interested in more details, you can find more at the link here on the slide, and there's even some YouTube videos. But I will tell you, our ClearCut tool has 2 different modes of operation. One of them is it uses a kind of traditional random forest model to learn these things have been labeled as malware transactions. We had to provide a bunch of malware transactions. And these things have been labeled as totally legitimate transactions. We do what's called featureization. That is, we break down the text of the HTTP logs into basically a set of numbers that we can do computations with. And all this code is available in there and documented so that you can use it and mess with it to featureize your own logs the way you like them. And then we train them through this algorithm called random forest that basically says it creates a bunch of individual decision trees. It says if this random feature that I took out of the data set for an individual line, this random feature splits the data, this other random feature splits the data, it makes a tree until you get to the end and then you have a yes or a no. Was this malicious or was this benign? And it's a random forest because it creates a bunch of these random decision trees, many of these decision trees. And each time, basically, it goes through and computes all the trees and basically averages them out at the end. And then you get the average answer, yes or no. It's very effective. It's pretty quick. I won't say it's super quick, but it's pretty quick. And it does a great job of cutting down the logs that you have to look at. I think in our tests, we found that we were only reviewing something like 0.01% of our logs manually after ClearCut ran on the random forest. So it still is a role for a human, but not quite at the scale that it would be impossible to do anymore. The other mechanism that ClearCut has is it has this unsupervised machine learning where they do a little bit of clustering with a kind of, unusual algorithm called isolation forests. And the isolation forests take the same features that the random forest does, but we don't have to tell it these are bad and these are good and train that model that way. What they do is they plot kind of a, this is going to sound like Doctor Who, but they plot like a 104 dimension matrix. and it's all timey-wimey, wibbly-wobbly stuff. And then they look in that 104 dimension matrix to see which points are closest to the other points and which ones are farther away. And they do this by making a series of random cuts. And they say the number of cuts that you have to do to isolate that individual data point is a measure of how far from normal that data point is. So if you can do a relatively few cuts, it's very far from normal. If you have to do a lot of cuts, it's close into one of these dense, compact things. Again, I don't really have time to explain that in detail, even if I did understand it entirely. But definitely, if you're interested, go check out the tool, watch the YouTube video, and you'll see. Rob, you want to bring it home?
Bring it on home. All right. Our story is done. You know what to do when you're back in the office next week. Make a good plan aligned with your needs. Then go to Hunt and, oh, you're asleep. Thank you, everybody, for attending our presentation. I hope you found it enjoyable and educational.